let's take a look at some machines which transfer energy from one place to another, or from one form to another. And it's worth mentioning before we dive in here that we start with an input energy, and the output energies, both useful and wasted, both of these output energies will eventually end up warming up the surroundings a little bit, i.e. they actually end up as heat. That's the final resting place of energy, and that's why heat is very difficult to actually transform into other useful types of energy. So let's dive in. First of all, we have a CD player. Let's have a look. A CD player. So the input energy of a CD player is electrical energy. Electrical. The useful output energy is, of course, sound. And the wasted output energy is heat. And that's usually caused by the electrical currents in wires, because wires have resistance. Now, let's take a look at a torch. A torch contains batteries, and so batteries have a type of chemical potential energy in them. Chemical, and I'll just put potential energy. That chemical potential energy gets transformed to electrical energy, and then to a useful output energy of light in the bulb. We also get a lot of heat, and that heat is wasted. It's not useful to us, and it will heat up the surroundings a bit. A clockwork toy, once it's been wound up, will have elastic potential energy. And the useful output energy of a clockwork toy is usually kinetic or movement energy, so kinetic. You might also get some sound. Sometimes sound would be wanted for the clicks and the whirs. And wasted output energy, again, would get heat. Friction is a force, and it transfers kinetic energy, movement energy, into heat. So heat is also a wasted form of this machine, of a clockwork toy. A Bunsen burner has gas to start it off, and that gas has chemical potential energy. The useful output energy of a Bunsen burner is, of course, the heat, but it's also light, because if you couldn't see the flame, then that would be a safety issue and you may burn yourself. So I'd say light is actually quite useful in a Bunsen burner. Now, wasted output energy is a very small amount of sound. Very, very small. But it is there. In a hairdryer, we start off with electrical energy from the mains electricity supply, which drives a motor and a heater, so we end up having useful heat and kinetic energy as it blows the air onto your hair. Now, the wasted output energy of a hairdryer is probably sound. We don't really need it to be noisy. And so there we are. Here are some energy transfers of machines, and just bear in mind that both the useful and wasted output energy types will eventually be transformed into heat to heat up the surroundings.